The year 1967. The man, Benoit Mandelbrot. The discovery, fractals. Fractals, you see them in clouds, in trees, in mountains, in DNA, in the human body. Fractals are the reason your cell phone can easily fit in a pocket or purse. George Lucas, the director of Star Wars, used fractals to catapult cinema audiences into new solar systems. Using fractals, he introduced the dreaded Death Star and rocked Hollywood to its foundation with his stunning computer-generated animations. Okay, so what are fractals? Today, in Fractals 101, first, we'll take a crash course in fractal geometry. Then, we'll look at the many uses for fractals in medicine, technology, and art. And finally, I will introduce the man who discovered the hidden geometric dimension of fractal geometry. And now, the crash course. Prior to 1967, we lived in a world governed by straight lines and exact shapes, squares, circles, and triangles. We used classic math to build our cities and create our world. We simply had no way to measure irregular shapes, such as clouds or the human body. Fractals, however, are this missing link. According to Edya Patzerlik in An Introduction to Fractal Geometry, a fractal is an irregular shape with repeating self-similarity. A tree is an excellent example of a natural irregular shape with repeating self-similarity. Notice the pattern as the tree branches out from the main trunk to main branches to daughter branches to tiny twigs. Each is self-similar and the pattern repeats as the branches become smaller and smaller and smaller. The tiniest twig represents the same pattern as the main trunk. Now, let's branch out to a new kind of fractal geometry. This fractal is called the Mandelbrot set and is computer generated. We're going to zoom in on this area right here. Notice that this shape is the same as this shape, which is the same as this shape. On a fractal, no matter how far you zoom in or zoom out, the pattern always repeats. Also, the farther we zoom in on a fractal, the more bends and bumps and repetition there is. So, if we were to measure this fractal or measure something using a fractal formula, the farther we zoom in, the more accurate our measurements would be. Let's zoom in and put this fractal concept to work. We're going to use Mandelbrot's fractal cosine equation, f squared plus c equals f, to measure a well-known irregular shape, Nebraska's border with the Missouri River. This fractal formula states that if I measure the border with large 100-mile-long units, the border is 300 miles long. However, if we zoom in and use smaller, more accurate 25-mile-long units, the border is 350 miles long. Now, did the border actually grow in length? No. Using smaller, more accurate units of measurement results in an ever-increasing length. Just imagine if we were to have measured in inches. Border measurement is not the only use for fractal geometry. Scientists and inventors quickly took advantage of the new geometry and applied fractal technology to modern medicine. Prior to 1967, we had no way to measure or interpret the irregular boundaries of our bodies. Fractals, however, changed everything. According to James W. Bayish in Perspectives in Cancer Research, fractals can provide an accurate method for predicting cell growth and diseases such as cancer in the lungs, liver, and kidneys. In technology, One of the most common uses for fractals is in the size reduction of cell phone antennas. According to Tom Vernon in the article Radio World, by using a fractal to micro-downsize an antenna pattern, size is drastically reduced while high-quality reception is maintained. As for fractals in the art world, this Jane Barnes shirt is an example of how fractals are used in today's art and textiles. Jane Barnes established her menswear company in 1977 and soon discovered the design possibilities of fractals. Using her computer, Jane has designed many stunning fractal patterns. Designs found in her shirts can also be found in nature. A leaf, rippling sand dunes, a nautilus seashell. These fascinating shapes have come to play such an important role in our lives, mainly due to the research done by one man. I would like to introduce Benoit Mandelbrot, whose discovery of fractals changed our lives forever. Benoit is still living. He was born in Warsaw, Poland in 1924. As a young Jew, he endured years of terror under Hitler's reign in the 1940s. For 4 years, he evaded arrest during the Nazi occupation of France. Then, in 1958, he emigrated to the United States and began working for the IBM Research Institute. Then, in 1967, Benoit published his first paper, How Long is the Coast of Britain, which brought the academic world to a standstill. In an interview with Mandelbrot about his paper in 1984 with Anthony Barcelos, it took the genius of Benoit Mandelbrot to describe mathematically what had seemed impossible. Using his newfound fractal geometry, Mandelbrot was able to describe clouds, trees, and even mountains. Without the insight provided by this man into changing geometry, cell phones would be limited to huge analog antennas, cancer research decades behind, and I would not be wearing this fractal art shirt. Fractals. They are the art, geometry of art, nature, and technology. They can measure trees and clouds, and even predict cancer. Thanks to the genius of Benoit Mandelbrot, these fascinating shapes are just as important in our lives as the circle, the square, and the triangle.